And a big g'day to everybody up there, Swan Hill and surrounding region. This is a recorded video of a presentation that I've given Graeme Anderson at the Future Farm Forum that was hosted by the North Central CMA on April 14 at Swan Hill. So today I'm just going to talk about seasonal forecasting and climate, and I guess when I speak to a lot of farmers, and one thing people are after a better forecast. Well, thankfully, in the last 30 years, forecasts are getting better. Bigger computers, a lot more data and measurements from ocean and atmosphere, and also a lot better understanding of which area of oceans affect which part of Victoria. So that's all good. But there's also another key bit, which is about making sure we understand what forecasts can and can't do, which we'll cover a little bit today. And also, I guess, irrespective of forecasts, this is probably one of the most critical ones, which is all those things that are under the control of farmers around, what they can do to manage seasonal risk, and those tactics, tools, and decisions that they can make, and that really help deal with that variability from one year to the next. So all of those things are helpful, and I guess we're just part of a project which is working with a bunch of collaborators to try and improve this middle bit, which is about how we get good information in the hands of farmers. Okay, so rainfall in the last 3 months. This is a decile map. So deciles, just if you haven't seen them before, just compares recent rainfall to long-term records. So decile 1 shows where that's the driest 10% of years equivalent, and decile 10 is where rainfall was in the equivalent of the wettest 10% of years. So if we look at January to March rainfall, most of it's been pretty average. A few areas were decile 8 to 9, but as typical with summer, lots of scattered thunderstorms around, and there's probably a lot more variability than what shows up there on that map. Yeah, and 2015 rainfall, can sort of see here, a lot of further down south was decile 1, and around your part of the world, part of decile 1 and some decile 2 and 3, so pretty dry. We were a bit unlucky last year. We just missed out on a couple of rain events that went over across the border, and so that's there was, while we had the ElNino one, there was a bit of moisture still popping around, so we were just a bit unlucky to miss out, and that would have made the world of difference. And just looking at the last 2 years of rainfall, 2014 and 15 combined, you can sort of see pretty similar there for the last 2 years. And some parts of Western Vic have had the driest 2 year period on record. So a bit of variability, but again, you don't have to go too far north, and places have been average. So he's hoping this year will be a bit better. Now, we don't have to go back too far. 2010 and 11, the Bureau tells us that was the wettest 2 year period in Australia's history. So it wasn't just wet in your part of the world; it was wet all the way up to Broome. So we'll just talk a bit about where did all of that moisture come from, and what's the difference between those wet years and dry years. And also just talk about, I guess a lot of farmers have noticed that in our, Victoria's reliable cool season rainfall since, so which is that April to October rainfall, since 97, we've been in a bit of a dry pattern since then. And it's not just been here, it's been in parts of WA as well. And we'll just talk a little bit about what's going on with that. Now here we've got a terrific long rainfall record. So it's a long-term one for Swan Hill, goes back to 1865 all the way through to 2015, and what you can see here is this is the 300 millimeters. This is the long-term average. Here is 337 millimeters is that line there, and you can see some years we're up to 600 millimeters rainfall, and some years less than 200. So a huge amount of variability in the rainfall in this historical. And you can see some runs of wet years and runs of dry years. Yeah, the Federation drought and World War II. You can also see, that last 20 years, probably Swan Hill's probably fared okay there. There's a lot of other parts of Victoria which have probably only had 2 or 3 years above the line there, but a lot of variability. So we'll talk a little bit about what makes the difference from those really wet years to those drier ones. I guess you're coming off, importantly, the 4 dry years in a row. Now here's that longer term summer record for Swan Hill, 67 millimeters, so not a lot of rain over the months of summer, but you can see every now and then, there can be the odd really wet one. Remember that summer of 2010-11, and I guess it's always a bonus when it does turn up for some and others that don't want it, but it's always pretty patchy because it's in that thunderstormy sort of pattern. So autumns in Swan Hill, long-term average 81 millimetres. Again, a lot of variability there in that longer-term record. I guess you can see some drier periods there around World War II where autumns are a run of drier autumns. And probably in the last 20 years, autumn breaks have been a bit less reliable than they once were. Probably in those last few years, you've had a bit of a better run than other parts of the state, but it's probably very event-driven. Winter rainfall, long-term average 96 millimetres at Swan Hill. So you can see a lot of variability again there. And, no really strong trend there. Probably just the lack of some of those wet winters there in the last 10. And spring rainfall, a lot of variability, again, in important season. You can see a run of dry ones there around the Federation drought and quite a run of sort of drier springs there back before World War II. I guess, the key thing in your minds up there is just the last four springs have been a bit disappointing and, only a bit around 50 millimetres, which is not ideal. And I guess one of the things to just talk about is what's the difference between those, especially for those bigger winter and spring years, and what's behind those wetter years and dry years for this part of the world. And I guess this picture is one of my favourite ones. Here's a picture of Antarctica, and you can just see southern Australia here, and the key climate drivers that are behind those really wet years or dry years. And to make rainfall in this part of the world, we need a good supply of warm, tropical, moist air, and that either comes from out here in the Pacific, and there's the ElNino Southern Oscillation, and some years it sends us more moisture, and some years it doesn't send us much at all in those ElNino years. And we've also got the Indian Ocean Dipole, which can be either in a helpful mood, sending plenty of moisture our way, or a years like last year where basically in spring last year the ElNino tucked into its drier phase and the Indian Ocean tucked into its drier phase as well. And so I guess that means that when we've got weather events heading down south, they're always trying to tap into a source of moisture, and if there's years where those oceans aren't being particularly helpful, then they correspond pretty well to those drier years. You can see along south here these sort of cold fronts whiz around the Southern Ocean. That's the southern annular mode, really important climate driver for us, and part of that's the triggers which helps, I guess, create rain is where we get cold events meeting up with good flows of tropical moisture. So that's the combination they're looking for. So seasonal forecasting is really always providing commentary on what these oceans are up to. So if you think of 2006, we had an ElNino in the Pacific, so not much moisture coming out of here. The IOD was in its dry phase, and those two both teamed up in their dry phase last spring. If we look at September, spring 2010, we had LaNina in the Pacific, lots of extra moisture coming in, and the Indian Ocean Dipole was in its wet phase as well. So in those sort of years, there's plenty of moisture to tap into whatever weather events we get. So that's why the seasonal forecasting is really just some background commentary on how those oceans are setting up for the winter and spring ahead. And to give you an idea of what a dry pattern looks like, here's September 2006, and this is a temperature anomaly map for sea surface temperatures, and you can just see these colours here is where a bit of ocean might be 2 degrees warmer than its long-term average, and these bluer colours represent areas that's a bit cooler than its long-term average. So you can see here there's an ElNino, and a lot of warmer water than average out there. That's where there's extra cloud cover and moisture, and it tends to be more rain out there in those years. But you'll notice these really important areas for our weather systems. These area of oceans, when they're cooler, they're actually letting out less moisture for us to feed into our rainfall events. So that's sort of pretty typical of a dry pattern. And 2006 and really last year's spring started to look like that as well. Now just keep an eye on this particular area and see if you notice the difference when we go to a wetter sort of a pattern, which is from the spring of 2010. See if you can notice any difference. Okay, so there we have it. There's the LaNina from spring 2010. You can see the big LaNina in the Pacific, but importantly, all of this sort of area of ocean was a lot warmer than average. And when it's like that, there's a lot of extra cloud, a lot of extra moisture, and that's there and available to feed into these weather events when they're happening down south. So it doesn't guarantee they fall over the right farm at the right time, but at least the preconditions of the season, especially for winter and spring, are better when there's extra moisture flows up there. So seasonal forecasting is largely about giving us updates about how those oceans set up for winter And for that Swan Hill rainfall record, when we look at previous El Nino events and we look at August to October rainfall, those 33 El Nino events, you can sort of see rather than normally a third of our springs would be decile 1 to 3, and a third would be average, and a third would be wet, decile 8 to 10. But when we just pick out those 33 El Nino years, you can see that 2 out of 3 of those springs were decile 1 to 3, so it doubles the chance of a dry spring. You can see a third of those years were average or wet, and that just means we had a couple of rain events and they might have tapped into moisture at perhaps from the Indian Ocean or from another source. And you can see in those El Nino years that's the typical pattern, drier in Eastern Australia. In LaNina years, when there's extra moisture coming out of the Pacific, you can see in Swan Hill and that sort of spring rainfall, it's certainly more than 3/4 of those years were either average or wetter. So it really does sort of help to have a bit of an eye out to see, well, which mood is the ocean going to be in this year. Also, we've got the Indian Ocean Dipole. When it's in its drier phase, this is the parts of Australia that tends to get less rainfall. And again, when we look at whenever it's been in drier phase in the Swan Hill record, you can just see it sort of, half of those springs were in the decile 1 to 3. And when it's in its wetter phase, you can see quite a good correlation with this part of Australia. And in those wetter phases of the Indian Ocean, only 5% of those have been dry. So pretty important to know what it's up to. And again, most years, the ocean's sort of just doing its normal things, but if it might be every second or third year, if it's in a dry phase or wetter phase, that's where the seasonal forecast might be able to give a bit of a heads up. And seasonal forecasts really, a farmer sort of made the comment that it's probably a bit like getting the minutes of the latest Reserve Bank board meeting, that all it is, it's really just some commentary to see if the climate scientists are measuring some changes out there in the ocean. It's just useful to know when and which part of the ocean is important for your part of the world, and in winter and spring rainfall, and what's it up to this year. So that's sort of all forecasts are. They're just really knowing enough about it so you can get a quick heads up to see if you're in one of those years where there's more opportunity, or a year whether there's a bit more risk. And when's the best time to look at seasonal outlooks? Well, unfortunately, autumn's a bit of a less predictable time of the year, and a good analogy I use is to think about your footy team, or confidence in your footy team, that we all have great hopes for and aspirations in March and April, but basically the footy teams take a few months to get into the swing of things, and it's by about mid-season you're a bit more confident to know, is your team going to be in the top 4 or the bottom 4 or not. And I guess our oceans are a bit the same at the moment. They're just really setting up for the year ahead, and over the next month or two is really important to watch to see how they're setting themselves up for the winter and spring. So that's probably worth keeping in mind. And I guess that commentary, for those that don't know, we put out the Break newsletter. Dale Gray does a great job on that, and it's monthly commentary on what those oceans are up to with regards to Victoria. So commentary for farmers, and also the soil moisture probe updates, which Dale Boyd does. And if you're not getting those, just drop an email to Dale Boyd to get the soil moisture updates, or to an email to the Break, which I'll include in a minute if you want to get those free updates. And one of the things you'll get with the fast break is this table, and I'll just explain it because it's a pretty useful one. It's basically what it's got. It's got a bunch of seasonal forecast models from across the world. So the European seasonal forecast model, the Australian Bureau of Meteorology, the Japanese, US, NASA, Japan, UK, there's a bunch of them, and they're all pretty sophisticated seasonal forecasts. And Dale runs these, and these are the March runs, and he just looks at them to see, well, what are they saying about Victoria for April, May, June, or for the 3-month outlooks there, and then down here is the 3 to 6 month outlooks. But basically, each of those models, it just writes down on the table what are they suggesting for the Pacific Ocean, what are they saying for the Eastern Indian Ocean, and what are they saying for rainfall in our part of the world. And you can see just with the current one, there's a few of them on average. A few of them have got a slightly wetter signal, and one there with a bit drier down south. So that's just something to keep an eye on. These sort of tables are useful, especially when you're looking at them change from month to month. And if we go through to, say, last winter, where more than half of the models were picking up that drier signal, there were none on wetter. So, and some years they're a bit mixed, but some years there's a stronger signal. So that's just worth paying attention to, and certainly will be over the coming months. So this is the longer term. There's a bit more mix for that longer term outlook. So again, we'll try and make better sense of that as those oceans start to set up. One thing people often ask is, well, what's happened in the year, given we had the El Nino last year, what's happened after previous El Ninos? Now, Dale Gray's kindly crunched some numbers for us here. This is the Swan Hill rainfall, and this is all those previous El Nino years you can see there. And this is the particular April to October rainfall in those El Nino years. But he's then followed up with the year following each of those El Nino events, and this is the actual monthly rainfall of those years after El Nino events at Swan Hill, and you can see them all there. And I guess one of the key things to take from it is that when we're looking at April October rainfall, those years following El Ninos, the majority have tended to be either average or wetter than average. But just note there's been a few dry ones still, but these odds are certainly better than what we're looking at last year. I guess you can see 2006 there. When we look at 2007, it was followed up with a fairly dry year. When we look at years like 82, El Nino, the following year we had a huge March rainfall there, 113 mils. So we remember that fondly about how we came out of the 82 drought, and wish that would happen every year. But at the moment we're still waiting for that big dump of rain. Fingers crossed. Now, I guess I've largely just talked about good old-fashioned variability. So are there any curveballs, anything happening that's a bit different to that longer-term record? And I guess the Bureau sort of talks about temperatures is one thing that's a bit different from the last 100 years. And while it varies from year to year, each decade since the 50s has been warmer than the previous one. So that's one thing that's a bit different. And when we look at Victorian temperatures for the last 100 years, that's summer, autumn, winter and springs. I guess there's a bit of a warmer trend there in the most recent decade, and I probably point out spring in that out of the last 10 springs we've had a number of springs that have been quite warm, from 1 to 2 to even 3 degrees warmer than average. And I guess that's sort of largely what the Bureau's discussion is, that with that sort of broader warming trends, summer just gets bigger, so it just appears a little bit earlier, and that can sometimes upset our springs like last year. So that's one thing to watch, just about that trend that's happening behind the scenes. Another thing that's sort of been a bit of a surprise has probably been, while daytime temperatures have been getting warmer in spring, we've actually been in some areas having an increased chance of picking up some frost, and that's just largely due to drier air above us and clear night skies and pressure patterns. So some good work happening with the department and also GADC on understanding frost risk and strategies around dealing with that. I guess part of the culprit for both that sort of, some of that slightly drier conditions over our cooler growing seasons and also that frosty stuff is to do with this pressure pattern. Now, here's April to October pressure from 1950 through to the last year, and you can see that the pressure during that period varies from year to year. And also one thing to note that, well, in El Nino years we tend to have a higher pressure over Australia, and that's the, say, 67, 68. We've got the 82 El Nino there, the 97, 98, 2006 El Nino, and then last year. So you can see that's when there's those spikes in pressure. But I guess one thing just to notice that while we've got that variability there is a bit of a broader trend of that pressure pattern slowly nudging up, and since 97 I guess we've probably not returned to some of those previous low pressures that we've had prior to that. And so that's just one of the things, I guess that's the difference between good old-fashioned variability versus a little bit of that climate change signal, which is to do with that increasing pressure pattern over southern Australia. And I guess some work too recently just done by the AEGIC, which is a good link to go and look at if you haven't seen that little case study. But it was just looking at, since 2000, looking at rainfall patterns, and what they're basically just suggesting is that the difference between summer dominant or summer or uniform or winter dominant rain, those zones have just slipped south since 2000 if they analyse the 2000-2015 rainfall patterns compared to that longer term record. So that sort of matches with a lot of farmers have noticed. And I guess irrespective of whatever the weather throws at us, agriculture, does a great job at trying to deal with whatever weather we get thrown at. And I'm pretty amazed at how much grain our modern farmers can grow on pretty limited rainfall. So it's that's people doing an amazing job, and we've got improved technologies, equipment, genetics, a lot of systems which have been really improving how we deal with this sort of variable seasons and turn a few millimetres of rain into grain. There's also lots of other things which people have been doing, which is around improved farm and regional infrastructure, and it might be around storage or water or fodder or just even improved communications, which are all part of how we're getting better at improving how we manage all of this. Growth in local and global markets and value adding is always there's huge markets on our doorstep and potential there. Doesn't necessarily mean we get paid more for our product though, so that's where this whole improvement in business management and managing income and seasons of variable years is increasingly a really important part of farming. Always has been, but I think that volatility is just getting more and more important to have really good understanding of good business management. Really, when you think about farm planning, minimum tillage and soil, pasture cover, all of those things, or you think of the dust blowing around in the 82-83 drought, and you think of some of the dry years we've had in the last 10-15, it's been amazing how well farms are managed these days to deal with that. And soil, making the most of soil moisture when it happens. Summer weed control, conservation of moisture, use of soil probes, variable rate technology, all of those things, I guess, while sometimes it could be a bit scary looking at some of the climate informational trends, we've got all of these other improvements which are there, and it's just about how we're trying to put those together to deal with whatever the weather throws at us. And agriculture's always been dealing with a lot of change, and I guess I've just put down here just some of my observations about how a lot of farms across Victoria deal with that change. And it's interesting that we're not just talking about whether it's changing markets or changing weather patterns or changing technologies. I think these are the sort of changes that have always been there as part of agriculture, and there's these first decisions, which are things that we just sort of change as we're going through them. Then sometimes there's need for some bigger decisions, which are usually a bit more expensive or a bit harder or take a bit more thinking through. And they're things about what do we do if things are a bit drier a bit more often, or how do we handle this or change the enterprise mix or the business system a bit more. And then there's some tougher decisions too, which is really about thinking harder about what if something's not working for you, what is it that's under your control that you can change so that you're enjoying your lot in agriculture. And I'm pretty sure these things have always been there as options in agriculture, and agriculture's always been throwing us plenty of challenges over the years. I think the main thing is that you're working through and doing the changes that are right for you. So there you go, there's a quick climate update and update on seasonal forecasting. Hope that's been of interest. If you'd like to subscribe to the Break newsletter, please just drop an email. It's free, turns up every month. Or any queries on the presentation, drop me an email. So good luck, and fingers crossed there's a bit more moisture floating around later this year.